Note 6.5a, Quadratic Review. Example 1. Find the x-intercepts, the y-intercept, the axis of symmetry, the vertex, the real solutions, the extrema, the transformations, and find the domain and range for each graph below. There's just one graph for these notes. So let's recall the vertex form function. F of x equals a times x minus h squared plus k, where a determines the direction of opening, and then h comma k is the vertex. So before we write those on the box below, let's label them on the graph itself. So the x-intercepts is going to be where it crosses the x-axis. That'll be at -5, 0 and 1, 0. The y-intercept is when it crosses the y-axis. And that is at 0, -3. Or actually, it looks like it's a little bit less than -3. So we'll have 0, -3.3 repeated. So like -3 and 1/3. The axis of symmetry is the line that goes through the vertex. That line is at x equals -2. And then the vertex, that'll be h comma k. So right here, the x value is -2 and the y value is -6. The real solutions is the same thing as the x-intercepts. The extrema is this lowest value right here. That's a minimum. Transformations from the origin to the new vertex. It looks like it goes to the left, down, no reflection, and then it looks like it gets a little bit wider, so that is a vertical compression. The domain would be all real numbers, and the range would be from -6 to infinity. So let's go ahead and fill in those values down here. So your h value is -2, k value is -6. So your function will be f of x equals a, which is given to you as 2/3, x minus h, which would be x plus 2 squared minus 6. So this would be your function. The x-intercepts, you would write -5, 0 and 1, 0. The real solutions is -5 and 1. The y-intercept is going to be the -3 and 1/3. And then the extrema is a minimum. Axis of symmetry, we have x equals -2, and then the vertex h comma k would just be -2, -6. The domain is all real numbers from negative infinity to positive infinity, and then the range was from -6 to infinity. Transformations, if it ever doesn't specify, just assume transformations from the parent function x squared. So there's no reflection. there's a vertical compression. It goes to the left, and then it goes down. Let's look at the next example set. Example 2, factor. So in A, we have the expression 4x squared plus 7x plus 3. First, see if you can factor out a greatest common factor among the three terms. Looks like you can't here. So, because the GCF is just 1, so you proceed by identifying A, B, and C. A is the coefficient of x squared, B is the coefficient of x, and C is the constant that has no x next to it. From there you'll draw an x. A times C is 4 times 3. That's 12. And then we have B down here, which is 7. So we're going to find two numbers that multiply to give you A, C, which is 12, and then add to give you 7. If you can't find them right away, you can list out your factor pairs of 12. So you just list for 1, 2, 3, 4, and so on until you run out of the numbers that are smaller on this side. 12 divided by 1 is 12. 12 divided by 2 is 6. 12 divided by 3 is 4. And 12 divided by 4 would be 3, which is already used, so we don't need that. So if we add these together, our sums are 13, 8, and 7. We want to use the one with 7 because that's our B value. So from there, you write out your factors. We have x plus 4 and x plus 3. From there, you want to divide each of these numbers by your A value, which was 4. 4 divided by 4 is 1, so we have x plus 1. 3 over 4 doesn't reduce, so we slide the 4 to the front. 4x plus 3. And that's your factored form. So we'll write that on the blank. X plus 1 times 4x plus 3. And you can write those two factors in either order, since it's commutative. Let's do B. 10x squared plus 13x minus 3. The GCF of all three of those terms together is 1, so we just identify A, B, and C. A is 10, B is 13, C is negative 3. From there we'll draw an x. A times C is 10 times negative 3, negative 30. B is 13. From there you want to find two numbers that multiply to give you negative 30 and add to give you 13. Let's write out the factor pairs of negative 30. 1, 2, 3, 4, 5. Okay, and then from there you're going to write the other factor of each pair. Negative 30 divided by 1 is going to be negative 30. We want the smaller number to be negative though in this case, since our sum is going to be positive. 30 divided by 2 is 15. 30 divided by 3 is 10. 30 divided by 4 is a decimal, so we can skip it. And 30 divided by 5 is 6. We wouldn't write 6 here because we already have that. So let's find the differences. We have 29, 13, 7, and 1. We can use that second factor pair, since that's the B that we want. So we have 15, and we have minus 2. Divide these by A, which is 10, and reduce those fractions. We reduce the fractions, you should get x plus 3 halves, and then x minus 1/5. We'll slide each of those denominators to the front of the x's and have your factored form. 2x plus 3 times 5x minus 1, and that's your factored form. C, x squared minus 6x plus 9. Identify A, B, and C. A is 1. There's only one x squared here. If there's nothing there, assume there's one of those items. B is -6, and C is 9. Draw your x. AC is 9. B is -6. Write out your factors of 9. 9 divided by 1 is 9, 9 divided by 2 is a decimal, and 9 divided by 3 is 3. These are both going to be negative numbers. Looks like the second factor pair works. Divide by A, which is 1, and then write out your factors. So we have x minus 3, x minus 3. We have two of the same factor, so as a multiplicity of 2. So we're going to write x minus 3 squared. Let's look at D. 2x squared minus 12x minus 14. This one has a GCF of 2. So that means we could divide each of these terms by 2. So then we have 2 parentheses x squared minus 6x minus 7. So this is going to be your new expression you're going to factor. So let's identify A, B, and C. A is 1, B is -6, and C is -7. Draw out your x. AC is -7, B is -6. Write your factor pairs of -7, which is just 1 times 7. We want the bigger number to be negative and the smaller number to be positive, since our answer is going to be negative here. And we're going to divide by A, which is 1. So then we write our factors. And we also write that 2 in the front still. So in parentheses, x minus 7 times x plus 1. And that's your factored form. Let's look at the last two parts of this second example group. We have 49x squared minus 144. Now we could say that A equals 49, B equals 0, and C equals -144. But since B equals 0, you can use the special formula, difference of squares. The difference of squares formula is A squared minus B squared equals A minus B times A plus B. To find A and to find B, you just need to take the square roots of them. So if A squared equals 49x squared, the square root of that would be 7x. The square root of 49 is 7. The square root of x squared is just x. If B squared equals 144, then if you took the square root of those, you would get B equals 12. So if we put those A and B into the formula, you get 7x minus 12 times 7x plus 12. And that would be your factored form. Let's do F. 9x squared minus 81. It has a GCF that is greater than 1. The GCF is 9. So we could divide each of these by 9. So you have 9 parentheses x squared minus 9. This is a difference of squares because B equals 0. So you could do this either way. You could do it by factoring, or you could use the formula. Let's use the formula. So if a squared is x squared, and b squared is 9, to find a, we take the square root of each side. To find b, we take the square root of each side of this. So a equals x, b equals 3. Plug it into the formula, and don't forget that 9 at the front. So we have 9x minus 3 times x plus 3. And that is your factored form. Alright, let's look at example 3. Solve by factoring. There's no GCF that's bigger than 1, so just identify A, B, and C. Draw your x. A times C is -6. B is -1. Write your factor pairs of -6. Put 1, 2, 3, 4, so on. 6 divided by 1 is 6. 6 divided by 2 is 3. 6 divided by 3 is 2. And we're done with that. The bigger number is going to be negative, and the smaller number is positive. Looks like the second pair is what works. We'll go ahead and write those. Divided by A, and then write out your factors. So we have x minus 3/2, and then x plus 2 divided by 2 is 1. With your 0 property, we set each factor equal to 0 individually. For solving this one, add 3/2 to each side. For this one, subtract 1 each side. So your two solutions are x equals -1 and x equals 3/2. And let's look at B. X squared minus 9x plus 20 equals 0. There's no GCF bigger than 1 here, so let's identify A, B, and C. A is 1, B is -9, and C is 20. Draw your x, AC, 20, B, -9. List out your factors of 20. 1, 2, 3, 4, 5, 6, and so on. 20 divided by 1 is 20. 20 divided by 2 is 10. 20 divided by 3 is a decimal. 20 divided by 4 is 5. 5 was already used, so we're done with those. It looks like our product is positive. Our sum is negative, so that means that both of the numbers are going to be negative. So we're going to use the last factor pair here, -5 and -4. Divide those by A, which is 1, and then write out your factors. So x minus 5 times x minus 4 equals 0. Use your 0 product property. Set each one equal to 0 separately. So x equals 4 and x equals 5. Those are your two solutions. Alright, 2 more examples. On C, let's go ahead and do it using the factoring method. A is 1, B is 0, C is -25. Now we could use the difference of squares formula, but for this example, let's go ahead and just do the x factor method. AC is -25 and B is 0. Let's list out the factor pairs of -25. So we have 1, 2, 3, 4, 5. Okay, 25 divided by 1 is 25. 25 divided by 2 is a decimal. 25 divided by 3 is also a decimal. 25 divided by 4 is a decimal. And 25 divided by 5 is 5. So we have 24 and 0. So we're going to use this factor pair right here. 5 and -5. divided by a, which is 1. And then we have x plus 5 times x minus 5 equals 0. Use your zero product property to solve for each of the solutions. Subtract 5, add 5. So there you have the two solutions, -5 and +5. You could also write it as plus or minus 5. You can also solve this one by taking square roots. We'll explore more of those kind of examples in the next set of notes. Let's do one more example for this one. D. X squared minus 10x plus 25 equals 0. Identify A, B, and C. A is 1, B is -10, and C is 25. Draw your X. AC is 25, B is -10. List out those factor pairs of 25 again, and we know that it's just 1 and 5. We don't have to write each of those every time. They're both going to be negative here, and we're going to use the second one. -5 divided by A. So then we have our factors, x minus 5 times x minus 5 equals 0. So use your zero product property, add 5 to each side. So your solution is x equals 5. It's a repeated real solution. Alright, go ahead and try the practice for the quadratics review. Refer to the rubric so you can see where to get to the activities. Once you finish the practice, then do one of the cherry quizzes for this topic, and then move on to the next topic. To review the rubric, remember, if you're working on a level 1 practice, click the links here. Level 2, right here, level 3 right here, and level 4 right here. And here are the quizzes that correspond to each of those levels. If you would like to make a copy of the rubric, you can make a copy on the Canvas page by clicking the appropriate link on the page.